Okay, so this is number 2, our word problem that we're going to try using the geometric approach to linear programming. So let's read through it. An investor has $5 million to invest in the housing market. Notice the correction from 10 to 5 I had to make. The original version said 10, but 5, it should be 5 million, so just take a note of that. So specifically in single-family houses in neighborhoods A and B. Once purchased, all housing units will be converted into rentals. In neighborhood A, houses cost $500,000 each. Really, that's on average, but for simplicity, we'll say $500,000 each. And bring in a profit of $600 per month when converted to rental. In neighborhood B, on the other hand, houses cost, on average, $100,000 each and bring in $320 per month in profit when converted to rental. Okay, so we have two different sets of figures associated with the two different neighborhoods. In neighborhood A, we have $500,000 for a house. That's how much it costs to buy a house on average in neighborhood A. And then once you rent it out, you're making $600 per month. Okay? Neighborhood B has the figures $100,000 to buy a house on average, and then once you rent it out, you're getting $320 per month and that's in profit. Right? It's not the rent, that's the profit that you make. Right? So already we see that there are some constraints on what the investor is going to be able to do. That's her budget is only $5 million, so you can only buy so much with $5 million. So that's one constraint that's going to be mathematically an inequality that we're going to write down. Okay, so let's keep reading. To encourage home ownership in neighborhood B, the local government has enacted legislation limiting the type of investment to a maximum of 30 units per investor. So whatever this investor does, she's going to only be able to legally purchase 30 units out of neighborhood B. All right. So how should this investor allocate her $10 million? Sorry, that should be 5 million. Let me cross that out. 5 million. Her $5 million in order to maximize her monthly profit. Okay, so we're going to write down a profit function, right? And we're going to wonder how to maximize that. All right, the additional question that we're going to answer is how much is that monthly profit if she allocates according to the, what our findings are going to be. All right, so first step is we want to write down the profit function. So for neighborhood A, first step is we need to say what our variables are. And I've already done that over here, so let's read through that. So the variables are fairly obvious. The X is the number of units purchased in neighborhood A, and likewise Y is the number of units purchased in neighborhood B. So X and Y, once we find them, are going to tell us how much she should purchase from each neighborhood. Okay? So with that interpretation or understanding of X and Y, let's write down the profit function. Well, and it's a per month profit. If she makes $600 per month renting out units in neighborhood A, then 600x is her profit that she makes from neighborhood A, right? And then likewise 320y is her profit that she makes from neighborhood B once she has determined what X and Y are, right? And then the total is the total profit. So this is our objective, right? This is our objective function. Now let's write down the inequality constraints. So let's start with the $5 million. So whatever it is, it has to be less than 5 million. That's whatever she invests has to be less than 5 million. So let's write that. So that's 5 million, 6 zeros. Okay. So scoot that over there. What has to be less than 5 million? It's what she spends buying houses. So if she buys X houses in neighborhood A and each one costs 500,000, then 500,000 times X is what she spends buying houses in neighborhood A. Likewise, 100,000 times Y is what she spends buying houses in neighborhood B, right? Okay, now we should simplify this inequality because there are a lot of zeros there. We can knock out 5 zeros, right? That's equivalent to dividing by 100,000. So if we divide everything by 100,000 here, we get 5x plus y less than or equal to 50. Okay, so let me just go ahead to save space. I'm just going to shift this over here and just replace that old form of the inequality with this simplified version. Okay, so we have that. What else do we have? We have the legislation enacted. That tells us that whatever she buys from neighborhood B has to be less than 30 units, 30 housing units. So since Y is the number of units purchased from neighborhood B, that simply says Y is less than or equal to 30. And then finally, because you cannot purchase negative housing units, we have our non-negativity constraints. Okay, so we have our inequality constraints together with our non-negative constraints, and then and those are just called the constraints, right? And we have our objective. So we're ready to start working. So what we want to do is we want to draw the region, okay? And we're going to consider the lines formed by turning these less than or equal to signs into equal signs. So let's write those down. 5x plus y equals 50. What is that going to look like? We'll graph by intercepts. Let x equal to 0. That tells us that y equals 50, right? On the other hand, if y equals 0, that tells us that 5x equals 50 or x equals 10. All right. Now, on the other hand, y less than or equal to 30 is just going to be y equals 30. That's a horizontal line if you remember your college algebra. All right. So let's draw this. You don't have to make a perfect picture. We want to get the intercepts in the right relationship with each other. Okay, so if the y-intercept is 50 and x-intercept is 10 for this line, I can draw something like this, a little bit higher up the y-axis than we are out on the x-axis. So over here we have 50, all right? Over here we have 10, right? Then if I want to plot y equals 30, that's going to be right about here. Okay, now we're going to shade in the region. So let me just label this as this is y equals 30, right? And this line is the line 5x plus y equals 50. Okay, 5x plus y equals 50. Now the inequality constraints being less than or equal to tell us that we're going to shade below the lines, and then non-negativity constraint tells us that we're going to be all in the first quadrant. So that's our feasible region. Okay, now it has 4 corner points. It's a polygon with 4 corner points. Let me sketch those in. Now we want to know the coordinates of those corner points. That's the main, it's the kind of the main part of the game. The origin, that's easy, 0, 0, right? And then this point out here is x equals 10, y equals 0. So it's 10, 0. This point over here, we don't know. We have to figure out. And then over here, if I can kind of scoot some of this stuff. Okay, hold on. Let me scoot this over. Okay, so this point here, the y coordinate is 30 because this is y equals 30. So the y coordinate is 30, but the x coordinate is 0. Okay, so we have 3 corner points so far. If I make a chart or a table that lists up the corner points, I can start listing them out. 0, 0, the origin, right? And then 10, 0, That's this point over here, and then 0 through 30, right? And then the unknown one we don't know yet. And then in the next column, we're going to have P, which is 600x plus 320y, and we're going to calculate for each of the corner points. But we have to find this unknown corner point. To do that, we need to solve the system. Okay, we need to solve the system 5x plus y equals 50. That's the equation for the first, that slanted line, and then the horizontal line simply has the equation y equals 30. Now, this is pretty easy to solve because y is already found for us. So we just take this y, plug it in for that y, and we can solve for x. So we get 5x plus 30 equals 50. Then 5x is 20 by subtracting 30 from both sides, and then dividing by 5 on both sides. X is 4. So the corner point that we get has x coordinate 4 and y coordinate 30. So that's what this point is 430. Alright, so we put that here in our table, 430. We go about calculating, okay, plugging in the origin to this expression, right? We're going to plug in each point to this expression. First, the origin gives us 600 times 0 plus 320 times 0. That's just 0. And then plugging in 10, 0, I get 600 times 10, which is 6,000, plus 320 times 0, which just adds a 0, to 6,000. So I'm left with 6,000. Then likewise here, I have a 0 for x, so the 600x is just going to go away. It's just 0. And then I have 30 for y, so it's 320 times 30, which is, well, it has two zeros, and then 3 times 32 is what? 96. And then if you plug in 4 and 30, right, I get 600 times 4, right, plus 320 times 30, right? I already calculated 320 times 30, so I know that's 9,600, and then 4 times 600 is 2,400, so it's 9,600 plus 2,400. Anyway, that comes out to 12,000. Okay, 12,000. Okay, so this is the maximum, right? This is the maximum. This is the max. So we found it. Now we just have to interpret it, okay? So, kind of scoot this. I'm going to scoot this over here and insert some interpretation over here, okay? So, the final answer really is the following: that she should buy what? 4 units in neighborhood A and 30 units in neighborhood B. And of course, the profit will be, if you do this, if she does this, the profit will be $12,000 per month. Okay. If you really want for extra points, you can figure out, you could give your answer in terms of how much money she actually spent. So 4 units translates into $2 million. 4 units in neighborhood A, so 4 times 500,000 is $2 million. So she should invest $2 million in neighborhood A, and then 30 units in neighborhood B means what? That's the other $3 million in neighborhood B. and that's it. So 2 million in neighborhood A, 3 million in neighborhood B, and if she does that, $12,000 per month will be her profit.